Hi everyone. In this video, we'll be exploring different transformations in data flows, specifically trim, join, and filter. We'll walk through each transformation step by step to understand their purpose and how they work in a real-world scenario. Master industry-ready skills effortlessly with our channel, covering Python, free AI tools, data engineering, generative AI, cloud fundamentals, and more, perfect for beginners, researchers, academics, and professionals. Subscribe now, hit like, and share with your friends and colleagues to stay ahead in the AI revolution. We have a storage blob containing two different files, sales data and product data. Our goal is to perform the following transformations. Trim, to clean up unnecessary spaces in the data. Join, to merge relevant product attributes with the sales data. Filter, to extract only the relevant records. The sales data file contains a product column. The product data file includes additional attributes, such as parent brand. Our objective is to bring the parent brand information into the sales data using a join transformation. Additionally, the sales data contains location details like Chennai, Bangalore, and others. We'll use a filter transformation to extract only Chennai sales data along with the parent brand. After applying these transformations, we will store the processed data in another storage blob as a refined output file. Let's dive into the demo and see how this works in action. Here we are in our storage account. Today's task involves working with the source files. The source files are in the folder named raw data. These are the two source files, products.csv and salesdata.csv. Let me open the sales file. Click on Edit. Here, you can see that the sales data contains comprehensive information about sales, including a field called item name, which highlights the corresponding product details. Additionally, the sales data includes entries for various locations, such as Chennai, Hyderabad, and others. Let's consider a scenario where a representative from Chennai head reaches out, requesting Chennai's specific sales data along with the parent brand information for each product. The parent brand information, such as Levi's, unbranded, Peter England, and so on, can be found in the product table. The sales data includes fields such as item name, category, and so on, but the additional information regarding the parent brand is not directly available in this table. To fulfill this request, we will merge the product table with the sales data and extract only the relevant details, sales data for Chennai along with the corresponding parent brand information, and create a resultant single table with only the required columns. During the initial exploration of the sales data, I identified an issue that needs to be addressed before proceeding. Specifically, the item name field in the sales data contains spaces. For instance, you can observe entries like jeans Levi's having space. These discrepancies prevent an exact match when attempting to join the sales data with the product information in which you do not see a space in jeans Levi's. To resolve this, we need to apply a transformation step to trim the spaces in the item name field. Once the data is cleaned, we can successfully perform the join operation between the sales and product tables. Now let us click open our Azure Data Factory. Click on Launch Studio to begin working with the data in an interactive environment. Let us now click the Author tab. Under Datasets, we can see the list of all the source and target datasets we have created in our earlier session. I will now proceed to create the transformation. To begin, I will create a new data flow. If you do not know how to create a data flow, then refer to my previous video for a comprehensive tutorial on data flow creation. Click Add Source now. Here we have to add our first source dataset. Select the sales data _src from the drop-down and it is done. Next, I need to add another source to the data flow, which is the product dataset. Let me select the dataset from the drop-down. And I have successfully added it to the workflow. As mentioned earlier, during my exploration of the sales data, I identified some issues with the item name column, which require cleaning before proceeding. To clean the data, we need to use the derived column transformation. While in my earlier video the derived column was utilized for a different purpose, in this video, we will explore another application of this feature. Let us move down a bit. Let us pull it up for a clear view. Now we have to add the column name here. Choose the column item name from the drop-down. Next, we need to open the expression builder within the derived column transformation. In this interface, there is an option to search for functions such as trim. Specifically, I'll use the ltrim or left trim function, which trims any leading spaces from the item name field. Now let us select the column here to be transformed. Select item name. Additionally, you can combine ltrim with rtrim, which trims spaces on the right-hand side by using both functions together. This ensures that any unnecessary spaces are removed from both ends of the item name, effectively replacing it with a properly trimmed version. Now click on Save and Finish and we are done. Once the data cleaning is complete and the item name column has been trimmed, I can proceed to add and configure the join transformation. Click the plus sign here and look for join transformation. Now we have added the join transform. Let us pull it up a bit. This is what is the join settings. The left stream are the derived column 1 and source 1, while the right stream is nothing but the source 2. Now select the right stream dataset from the drop-down, which is the source 2, which contains the product data. The next step is to determine the type of join to be performed. For this purpose, an inner join has been selected, as it ensures that only matching records between the sales data and the product data are included in the final output. This type of join is ideal when we need to combine related data from both sources while excluding non-matching entries. Now, we need to define the join conditions. On the left stream, we select the cleansed item name column from the drop-down, which was created in the derived column transformation. This ensures that the cleaned version of the item name is used for accurate matching during the join process. Now we need to select the right side one, which is the name column from source to which has the product data. Let us select it from drop-down. We do not find the desired column name here. This means we have forgot to add the product data set to source 2. Let us do it right away. Click on source 2. Yes, it is showing 0 columns, which means no dataset added. Let us click here and select the product_src from the drop-down. Now we have successfully added the dataset to the source 2. Now let us go ahead and complete the join conditions. Yes, now here is our desired column getting reflected under source 2. We have now configured our join settings and ready for the next step. The purpose of the join is to combine additional attributes from the product table into the sales data. Once the join is configured, you can preview the result, which will now include all columns from both sources. For instance, it will initially display all 10 columns from the sales data along with the new fields added from the product data, such as parent brand, cost price, and tax. To refine the output, we will now use the select transformation. Here, we'll choose only the required columns, excluding the ones not necessary, such as the product name and category name. Here we select the name and the category name, which we do not require anymore. Now let us delete one by one. With the unnecessary rows filtered out, we have successfully completed the delete operation to remove the rows that are not needed. The dataset is now cleaned and refined, containing only the relevant information required for the next steps. Next, we'll filter the data to include only the Chennai location. To do this, I'll add a filter transformation and configure the condition using the location column. Under Filter Settings, click here on Filter On. In the expression builder, use the syntax. Location is equal to Chennai. Note that the equality operator is a double equals sign, is equal to. After applying the filter, the final output will contain only the required data for Chennai, meeting the project requirements. Let us now review once what we have done till now. First, the data was trimmed to address the spaces in the item name column. Then, a join operation was performed to combine the relevant data from the sales and product datasets. After that, we selected only the required columns, followed by filtering the data specifically for the Chennai location. Now, the final step is to sync the refined data by loading it into the target dataset. Let us click the plus button and then select Sync. Now, let's configure the settings for the sync operation. Let us now browse and select the path for the output dataset. Click on New. Select the storage as Azure Data Lake Storage Gen 2. Click Continue. Select delimited text since the output file will be in CSV format. Select the linked service already created. If you do not know how to create a linked service, then watch my previous videos in which I have demonstrated the process. Now you may rename the file here. Click the folder here to select the path for the output file. We want the output file in Processed Data folder. Now our path for output file is set. Click OK here. Now, let's configure the settings for the sync operation. In previous videos, I used the default settings, which resulted in the file name being generated as default. For simplicity in this demonstration, I'll use the output to single file option. However, it's important to note that this approach is not recommended for actual projects due to scalability and performance considerations. When using the output to single file option, it is crucial to set the partitioning to single partition for the process to work correctly. This ensures the file is generated with the specified name. Now we need to enter a file name here. For this example, I'll name the output file as Chennai_salesdata.csv. When using the output to single file option, it is crucial to set the partitioning to single partition for the process to work correctly. This ensures the file is generated with the specified name. We can also do it from here. Let me walk you through the process once again. We started with two files, the sales file and the product file. In the sales file, the item name or product name column contained unnecessary spaces, which we addressed by trimming the data. Next, we performed a join operation using the item name from the sales file and the corresponding column in the product file. After the join, we selected only the required columns for further analysis. Then, we applied a filter to include data specific to Chennai. Finally, we loaded the cleaned and processed data into the target dataset. That's it. This completes the end-to-end process of transforming and loading the data. Now let us rename the data flow for clarity. I have named it as Chennai Processed Dataset. Let us now publish it all. The next step is to create a pipeline. If you do not know how to create one, you may refer to my earlier videos for detailed guidance. Let us select the data flow activity now and drag it here inside our newly created pipeline. Now is the time to configure the settings by selecting our existing data flow, which is Chennai processed dataset. Let us rename our pipeline as Chennai Data Pipeline. Now, click on Debug to initiate the data flow debug process. As demonstrated in my earlier video, please note that this step may take some time to complete. Debug runs can take a few minutes, especially when working with larger datasets or complex operations. So, patience is key during this stage. Remember, the debug process helps us validate the data flow before committing it to production, ensuring accuracy and reliability. Now, as shown on your screen, the process is completed. Now, we're back to our pipeline. The next step is to click on the debug button here to execute and validate the pipeline. The action is in progress and we'll need to wait for some time for it to complete. Once the process is finished, we can review the results and verify that the pipeline has executed as expected. The process is still in progress and performing the necessary actions. Now that it has successfully completed, we can proceed to review the results and validate the output to ensure everything aligns with the requirements. Let's check the output now. We have to move to our storage account where we have our output file generated and stored. Click on Processed Data folder to view the output. The output file Chennai_salesdata.csv has been generated successfully. Move the slide bar towards right. Upon reviewing the file, you can see the sales data along with the new column called Parent Brand, which includes values such as unbranded and Peter England. Additionally, the data is filtered for Chennai as expected, displaying only the relevant records. As a reminder, since we used an inner join, only the matching records from both datasets are included in the output. With this, we've successfully completed the tasks for today's video and achieved the desired transformation and filtering. If you found this tutorial valuable, don't forget to subscribe to the channel, like the video, leave a comment with your thoughts or questions, and share it with others who might benefit. Explore the description for a link to our Udemy course, where you'll learn techniques to use generative AI to automate your daily tasks. Also, check out this YouTube channel for more videos covering Python, data engineering, ETL, cloud computing, generative AI, and much more. See you in the next video.